Hello everyone, welcome back to my channel. Today I am continue with the chapter applications of the derivatives. In this video we will start with the topic approximation. Firstly we will discuss about this. Firstly, in this approximation we will let the given function f of x will be equals to y, and del x denotes small increment in x, and we know that the increment in y corresponding to the increment in x, which is denoted by del y, and del y will be equals to f of x plus del x minus of f of x, and it is defined as, first, the differential of x is denoted by d of x, and it is defined by d of x will be equals to del of x, and secondly the differential of y is denoted by dy, and dy will be equals to f dash of x into dx, or dy will also be written as dy will be equals to dy upon dx into d of x, and the two curves intersect at right angle if the tangent to the curve at the point of intersection are perpendicular to each other. This is the important point. The two curves intersect at the right angle if tangent to the curve at the point of the intersection are perpendicular to each other. In case dx will be equals to del x is relatively small when compared with x and dy, it is a good approximation of del y. That means dy will approximately equals to del of y, and from this all above discussion, this is the point that the differential of dependent variable is not equal to the increment of variable, and whereas differential of independent variable it is equal to increment of the variable. Now next we will start with some example which is related to the approximation. Example is, use differentials to approximate root 25.3. In this, firstly we will take y will be equals to root of x. That means from this x will become equals to 25 and del x will be equals to 0.3. That means x plus del x will be equals to 25.3. And we know that del y will be equals to root of x plus del x minus of root x. That means now we will use this formula to finding the del y, which will become del y will be equals to root of 25.3 minus of root 25. That means here we get del y will be equals to root of 25.3 minus of 5. That means root of 25.3 will be equals to del y plus 5. Let this be the equation number 1. Now del y is approximately equal to dy. That means, and in the previous we will discuss that dy will be equals to dy upon dx into dx. That means here we get dy upon dx. That means del y upon into del x. This is the del x because it is del y because del y is approximately equal to dy. That means we also use here this y will be equals to root of x. So from this dy by dx will become 1 upon 2 root of x. That means here we get 1 upon 2 root of x, and dx is approximately equals to del x. That means it will become 0.3. So here we will also put the value of x, which will be equals to 25. So we get 1 upon 2 root of 25 into 0.3. Then it will become 1 upon, it will become 2 into 5 into 0.3. That means here we get 0.3 upon 10. That means it will become 0.03. This will be equals to the dy. Now from equation number 1, we get root of 25.3 will be equals to 5 plus 0.03. That means it will become 5.03, which will be equals to root of 25.3. So this is the differential by using the approximate method. Now next example is using differential, find approximate value of the cube root of 28. Firstly, in this we will take y will be equals to x raised to the power 1 by 3 because there will be the cube root. Then here we get x will be equals to 27 and dx will be equals to 1. Then x plus del x, that means dx will become 28. And here we will using the formula of del y. By using this formula, here we get del y will be equals to x plus del x raised to the power 1 by 3 minus of x raised to the power 1 by 3. Then we will put the value of x plus del x. This is the value of x plus del x. Because del x is approximately equal to d of x, then we get del y will be equals to 28 raised to the power 1 by 3 minus of 27 raised to the power 1 by 3, and 27 raised to the power 1 by 3 will become 3 raised to power 3 raised to the power 1 by 3. Here 3 will be cancelled out and here we get 3. That means 28 raised to the power 1 by 3 minus of 3. So therefore 28 raised to the power 1 by 3 will be equals to 3 plus del y. That means del y is approximately equal to d of y So we know that dy will be equals to dy upon dx into d of x. That means here we get 1 by 3 because y will be equals to x raised to the power 1 by 3. If we will find the derivative of y with respect to x, then we get dy by dx will be equals to 1 by 3 x raised to the power 1 by 3 minus 1. That means here we get 1 by 3 x raised to the power minus of 2 by 3. So we will using this value here, then here we get 1 by 3 x raised to the power minus 2 by 3 of dx, which will be equals to dy. And here we will also put the value of dy, which will be equals to 1, which is also approximately equals to del of x. That means here we get 1 by 3 into, and x will be equals to 27 raised to the power minus 2 by 3 into 1. That means here we get 1 by 3. 27 will also be written as 3 raised to the power 3 whole raised to the power minus 2 by 3 into 1. That means 3 and 3 will be cancelled out, and here we get minus 1 by 3, 3 raised to the power minus 2. That means it will become 1 by 3, and 3 into 3, 9. That means 9 raised to the power minus 1. That means here we get 1 by 3 into 1 by 9. That means it will become 1 by 27. So therefore from equation 1, 28 raised to the power 1 by 3 is approximately equals to 3 plus del y will be equals to 1 by 27. That means it will become 82 by 27. So by using differential, the approximate value of cube root of 28 will be equals to 82 by 27. Now in the next video I will discuss about some more questions of this exercise which is related to the approximate method. If you like my video, then please like, subscribe and share my videos, and do not forget to press the bell icon for the notification of the more videos. Thanks for watching.